So our next talk is Scott Poretsky from Ericsson. He will be talking about Zero Trust Architecture for Secure Open RAN working, right? And he's the Director of Security North America Network Product Solution in Ericsson. I had the pleasure of working with Scott. He's also an IEEE leader in IEEE activities, also in my previous job at AT&T. So we worked on many security-related topics. So just to briefly introduce Scott, obviously, as you can see, he has a prolific professional career. In addition to that, he has owned many IEEE volunteer hat as well, including IEEE Communication Society's Technical Committee for Communication Quality Reliability, CQR. He's in the advisory board. In fact, I have attended maybe 2 of your conferences.
You've been excellent.
And he has also led many security-related efforts in the standardization, including the ORAN Alliance Working Group 11 and ATIS Zero Trust Working Group. He also served as the Ericsson's delegate to FCC CISRIC 8 Working Group and Open RAN Working Group 3 and 5G virtualization. So as you can see, you won't be getting a better speaker on security talk about Open RAN than Scott. So with that, I will hand it over to Scott, but let me share his talk here. Let me see, your talk is, this is your talk, right? Oops. Yeah, this is your talk, right? I'll just share that. I'll just share that. Share. Okay, I'll just do Alt-L, Control-L, something like that. Coming up, yep.
All right.
All good, so you can just,
Terrific.
thanks, Scott.
Yeah, thank you very much.
Oh, sure.
All right. Hi, everybody. I'm Scott from Ericsson. Couple quick questions. Ashutosh let me know that there would be some students with an interest in security attending. Raise your hand if you're a student with an interest in security. All right. It's only 20 minutes, but I guarantee that this will really pique your interest so that you will want to learn more. I guarantee it. Who here is from industry and likes to use the word security? Okay. There are some of you that don't like to use it, probably because you're trying to avoid it. All right. So let's get into this. So we're talking about zero trust architecture for 5G and Open RAN critical infrastructure. There's a lot to unpack there because we have zero trust architecture, we have cybersecurity, we have 5G, we have Open RAN, we have critical infrastructure. In 20 minutes or less, we're going to hit all of that, just so you know then where to go and look at and do additional research on your own. The first thing you need to know is the US government is doing a lot of work on zero trust architecture right now. There are multiple agencies involved. Only a few, though, have produced artifacts, reports that are relevant for what we do in the telecommunications industry. Those would be CISA, NIST, the FCC, the NSA, ESF. Now, on top of all of those is the ONCD. Who here knows who the ONCD is? You need to know who the ONCD is. This is a new position in the White House. This is the Office of the National Cybersecurity Director. In March 2023 was published the National Cybersecurity Strategy. Let me move what's displayed here because it's blocking my screen. So this National Cybersecurity Strategy is very much focused on zero trust architecture for critical infrastructure. Our mobile networks are critical infrastructure. There are 16 sectors of critical infrastructure as defined by CISA, and telecommunications, or the comm sector, is one of those. That's important as we're securing Open RAN, because we need to keep in mind, as we're now putting our mobile networks in the cloud or on cloud native applications, this is critical infrastructure. This isn't just some mom and pop enterprise deploying in the cloud. We need to secure it differently. It's for that reason the NSA Enduring Security Framework a couple years ago published a 4-volume report that is ultimately the playbook for how to deploy 5G securely in the cloud. This is titled the Security Guidance for 5G Cloud Infrastructure. These 4 volumes total 100 pages. The 4 volumes provide very nice high-level directions we need to go for securing our critical infrastructure. Prevent and detect lateral movement. That's new in our 5G critical infrastructure. Securely isolate our network resources, protect data in transit, in use, and at rest, and ensure integrity of the infrastructure. Even if it's not your infrastructure and you're running on somebody else's infrastructure, you're responsible, and in the US courts, accountable for the integrity of the infrastructure that you're running on. The Zero Trust architecture is defined by NIST, the National Institute of Standards and Technology, which isn't too far from here. So Zero Trust architecture is in the NIST SP 800-207, and it's defined by 7 tenets. They're listed here, and you'll see at the top of those 7, I have 4 in green and 3 in black. Well, why is that? Well, the reason comes down to this lower corner here, the 3GPP study on Zero Trust. So 3GPP has an ongoing Zero Trust study group, and they just produced their first report, 33.894. I don't know if it's publicly available yet, but its findings are available. 3GPP, in their research on Zero Trust architecture, concluded that for the NIST 7 tenets, only 4 of them are applicable to 3GPP, which begs the question, who's going to cover the other 3? And yes, that could be opportunity for IEEE. They also decided, their second controversial conclusion was that they would focus on Zero Trust architecture for the core and table it for RAN for a couple of years. That's because the core is further along to align with a Zero Trust architecture because it has what's called a service-based architecture. So they thought, lower lift, we'll start with Zero Trust architecture for the core now, see what we learn over the next couple of years, and then start addressing Zero Trust architecture for RAN. At the same time, in the lower right corner, the ORAN Alliance has publicly announced it is pursuing a Zero Trust architecture. This was actually announced a year ago. Working Group 11, the working group responsible for ORAN security, considers Zero Trust architecture in everything we do. Security controls for internal and external threats. And that's a really key differentiator for a Zero Trust architecture, where we now need to consider internal threats, particularly as we're migrating our critical infrastructure to the cloud, where we're bringing in new third parties. We need to consider the internal threats. ATIS at the same time, so that's the North American standards body that feeds into 3GPP and others. ATIS at the same time has had its own 5G Zero Trust study ongoing. And I was fortunate enough to be the co-chair of this study group, along with Todd Gibson from T-Mobile. And we published our report for phase 1 of the study, 1-year study. We published our report last week. 50 pages that really help explain why we need Zero Trust architecture for 5G networks and Open RAN. Some of the key recommendations that we have. ZTA, Zero Trust architecture, as defined by NIST, is the evolution of Zero Trust, the concept. When you talk about Zero Trust architecture, you will have people say to you, oh, Zero Trust, that's just a concept. They're right, it is. But we're talking about Zero Trust architecture. Now the A on the end, that's the evolution to a plan from the concept. And this is defined by NIST in the SP 800-207. ATIS also concluded all 7 tenets of zero trust apply to mobile networks, not just 4 of them. So 4 of them may only be applicable to 3GPP. Someone needs to cover the other 3. Zero trust architecture applies to RAN and core equally. One is not higher priority than the other. While 5G has zero trust architecture features, it is not a zero trust architecture. However, we have the opportunity now to build in security and build in a zero trust architecture to 6G. So the lessons we learn with what we're bolting on in 5G, we can build into 6G. Another key thing, and this came from the OECD as well. The industry best practices alone are insufficient for securing critical infrastructure. What one operator calls best practice is not what another operator calls best practice. What one vendor calls best practice is not what another vendor calls best practice. And what one hyperscaler cloud provider calls best practice is not what their competing hyperscaler cloud provider calls best practice. So as the OECD has said, best practices are not working. We need to have these formalized as security specifications. In addition to that, in this report, Addis has identified 12 use cases for a 5G ZTA, 2 of which include Open RAN. And we also have identified 12 distinct critical zero trust architecture security control groups. And these are based on the federal guidance coming from multiple agencies. And what are those? So you can see here graphically, starting at 11 o'clock, we have strong data encryption and integrity checking, automated identity and access management with dynamic access controls. Just having access controls alone is not enough. And this is based on US federal government guidance. Strong mutual authentication with PKI and X509 certificates. Multi-factor authentication for your users. Not using password is one of the factors. Micro-segmentation, container isolation, tenant isolation. AI and ML for anomalous behavior detection. Threat intelligence, detection and response. So we're talking about EDR, endpoint detection and response, actually sitting on those servers, running our cloud native workloads. Continuous monitoring, logging, and validation. Continuous and coming from inside the network, not just at the perimeter. This is based on processes of secure software development. We have digitally signed images with SBOM, our hardware root of trust, and SIEM SOAR integration. Now you're looking at this and saying, this is going to take a long time and it's expensive. You are right. So CISA, in its zero trust maturity model, which version 2 just came out a couple months ago, and it's a great document. As they state in there, the path to zero trust is an incremental process that may take years to implement. But their important point is, don't wait for perfect security. Start taking those incremental steps now. And the zero trust maturity model has in it 4 stages for zero trust, starting with traditional, which really isn't the zero trust. That's our traditional perimeter security with firewalls and IP subnetting and zero trust network access, ZTNA, which is not ZTA. They're 2 very different things. That's traditional. When you start adding these controls incrementally, you move to the second stage, which is what's called initial, and then you have advanced, and then you have optimal. And in optimal, everything is fully automated and dynamic. So we have those 4 distinct stages for a zero trust maturity model. Most of the deployments we're seeing now are still at that traditional phase. The ORAN Alliance Working Group 11 has raised the security posture of ORAN. So the specifications now align with what CISA would call the initial stage. And we're working towards taking those next steps to advanced and optimal. And as the OECD also said, continued disruptions of critical infrastructure make clear that market forces alone have not been enough to drive broad adoption of best practices in cybersecurity. We need to formalize these standards because just saying that's a best practice isn't working. Now, we are taking all of this and using this in ORAN Working Group 11 and advising and driving security specifications in the other working groups. I've done some modification here to the ORAN architecture, annotating it with the attack vectors that we see, the primary attack vectors. And an attacker could go through the SMO, which is really the keys to the castle, because from the SMO, you can go anywhere. We have the RICs and the apps, including X apps and R apps coming from third parties. That's another attack vector. We have the new open front hall with the split, the disaggregation of the ODU and the ORU, and some weak specifications there, and I'll get to that in a minute, and OCloud. And while you say, well, ORAN might run on a cloud like everywhere else, it's just the same. No, that's not true, because in ORAN, we are specifying something called the OCloud for running your Open RAN workloads. That means if we are specifying our own OCloud for what will be used in critical infrastructure, we need to make sure it's secure. We have that responsibility. So in everything we do, we're considering the 800-207 from NIST. We're protecting from internal and external threats. And we are making each network function a micro perimeter, because in a zero trust architecture, each asset needs to be its own micro perimeter, because you have to assume the adversary is already inside the network. That's direct guidance coming from the NSA. So if we're building a ZTA, we need to assume that, and that we need to secure each asset, each network function as a micro perimeter. So when we look across the attack surface, and how much time do I have? Okay, good, that's all I need. So as we look across the attack surface, we have the SMO with AI and ML, and AI ML is also in the X apps. We have our cloud native functions, the ORU, ODU, OCU, and near real-time RIC. And then we have new ORAN interfaces, the O1, O2, the A1, E2, the Y1, which is particularly problematic because if we go back and look here, you'll see that Y1 is that new RAN analytics information exposure. We are exposing directly from the RAN an interface to the NWDAF in the core. This breaks the 3GPP model of security domains. Likewise, if you look in the upper right corner, you see that external interface to the SMO. We are importing AI data into the SMO to make intelligent decisions, such as energy efficiency, an excellent presentation we heard earlier. But what if we had a threat actor that poisoned that external data that's owned by another third party, and this is exported into the SMO to purposely, intentionally cause energy inefficiency? You could think how that kind of threat could be used in other manners as well. So we need to make sure that we secure everything with a zero trust architecture. If I were to be a threat actor, I would look at biggest bang for the buck, and the easiest place to attack the ORAN network and have the biggest impact would be those external interfaces to the SMO and that RAIE Y1 interface to the near real-time RIC. So when we look at the threat taxonomy here, you see the key places we need to secure, and this is where we have 14 active work item teams within Working Group 11 doing this work. We're securing the open front hall, the SMO, the RApps and XApps, the OCloud, and there's new ORAN features coming as well. New ORAN features, shared ORU. We're now creating a multi-tenant environment. There's the RAIE. RAN core data sharing is another one being standardized that has direct communication from the SMO to the core. We have the decoupling of the SMO based on a service-based architecture internal to the SMO. So if we're doing that, it better be as secure as the 5G core. And of course, we have AI and ML throughout Open RAN. That is a known threat vector, even outside of ORAN. That's a known threat vector. We need to make sure we are securely consuming data and have secure models for our AI and ML used across Open RAN. A couple of other places I want to point out where there's threats to the ORAN architecture. If you notice, there's that O2 interface between the SMO and the O cloud. I could be a malicious actor that gets into the O cloud, and across the O2 interface, I could then get to the SMO and work back southbound. If I get into the SMO, I could work across that O2 interface the other way and now get into the O cloud infrastructure and work my way back up from there. So we need to make sure all of that is secure as well. Working Group 11 has made tremendous progress in the standardization of zero trust architecture to move us to that initial phase, and we will continue to do that work. So to wrap up, 5G is critical infrastructure. Zero trust architecture is a new paradigm for how we secure RAN, and we need to apply it to Open RAN to protect from internal and external threats. It is an incremental process, but we need to start taking those steps now. Pursuit of a ZTA could produce the most securely specified RAN. And why am I saying that? Well, if 3GPP tables ZTA for 3GPP RAN for a couple of years, it's quite possible in a couple of years we look back and see that ORAN has leapfrogged the security posture of 3GPP RAN. Industry best practices alone are insufficient for critical infrastructure. We're not deploying enterprise applications here. Formal specifications are needed, and this is work we're beginning in Working Group 11, where you'll see we've have some new specifications just around secure use of APIs. ORAN Alliance Working Group 11 has made great progress. However, the vendors need to implement what's in the specifications, and what's available for ORAN open source also needs to implement what's in the specifications. Just because it's in the specs doesn't mean it was implemented. We need to make sure that happens. And when that happens, then we can say that ORAN is at the same level of security posture as 3GPP RAN.
I think it's such an interesting talk. Obviously, security is my area too. And I was reading your ORAN Alliance Working Group 11 specification. I think I sent you a mail, you sent me a link, and it's really very detailed. I really loved it. You know, it was—
It's a lot of work.
Yeah, threat taxonomy and all those. And the second thing you commented about open source guys implementing that, or even operators, whoever, right? The whole community has to do that. Where people have a lot of misgivings about, well, you know, my whole RAN is going to be open, you know, all those. So it's important to take that out of the doubts.
We need to apply due diligence.
Absolutely. You know, even talking about in the standards within IEEE Future Networks, we have a security working group as well. We try to see. So there are potential collaboration opportunity there too. Any question from any of the budding engineers? Or yeah, go ahead, please, Bob.
Technologies out there for hardening the hypervisors, the entities that create the virtual machines in terms of side channel attacks and things of that sort. Are you guys looking at those sorts of things and how to harden, some of these virtual machines we're creating?
Yeah, not yet. The work on the lower level infrastructure is coming, but that work hasn't started yet. We're working more at the application level. When I say application, that includes the network functions.
Hey, Scott. So quick question. Like, I remember during the 3G days and the 4G days, like the industry did work on the security aspect, but there was reluctance from the industry to accept the security solutions to be deployed, and there was not much of a push from the operators as well as from the vendors. But in your experience right now with what you are doing at ORAN, I think this is really critical. Do you see that the industry is embracing all the technology, the security solutions that's been proposed, or is it still, oh, this is not my problem?
it's a mix, and there's really a dividing line here. The operators are the most active, along with Ericsson and a couple other vendors in Working Group 11, because the operators understand they have to answer to regulators. So they want to make sure their networks are secure. So we have heavy involvement and support from the operators and a small set of vendors. There's another set of vendors that's actually a bigger group that says, we just need to get this out there and get it working. We don't care about security. So let's just move forward. So there is that. We see less of their participation in Working Group 11. They're not involved.
So I know we invited some summer interns, students. Some of you are interested in cybersecurity. You have any specific question, you can ask the expert here. Any of you, any question, don't be shy. Yeah, okay, we have another one. It's not a student, but
Yeah, I'm not a student yet, but quickly about the RAI feature you mentioned, is that information about RAT analytics going to the core, or it's getting exposed to individual users before it gets to the core?
No, users don't see that. That's going direct from the core. It's going direct from the near real-time RIC in the RAN to the NWDAF in the core.
Okay, got it, thanks.
So with that, unless there is a question from the student, we're going to wrap it up. You have a question? Anybody in the back? No? Okay. You can
Are
talk
you
to Scott.
excited about cybersecurity now?
Yeah, it's a very hot topic here at APL. So anyway, so let's appreciate the talk from Scott.